let's start with the first category called reciprocal trig identities. So what they mean by reciprocal trig identities is, let me screenshot so I can write here, is these properties. So you already know them, but I'm just going to remind you that cosecant is 1 over sine. So if you don't remember this, write it out again so that you can have it on your notes in several different places, so that way when you look at it for the test, you'll be like, oh yeah, I have this written down so many times, how could I forget? It is written all over my notes. Oh, I didn't expect the question mark there. But yeah, so cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And I'll give you guys like 15 seconds to write this down. Ten more seconds. 5, 4, 3, 2, 1. And if you, oops, didn't have it written, it's still right over there, so it's not like you can't see it. Okay, so we're going to simplify the bottom part to a single trig function with no denominator. So we are given cosecant times cosine. So cosecant, I'm going to highlight this, cosecant is the same thing as 1 over sine, according to our chart, I guess you could call it, on the top. So I'm going to write 1 over sine times cosine. So I literally just replaced cosecant with 1 over sine because cosecant is 1 over sine. And then we're just going to combine this into one single fraction. So 1 over sine times cosine is cosine on top and sine on the bottom. Don't know why I'm having trouble writing today, but cosine over sine. Okay. And then, let me just remind you that since tangent is sine over cosine, cotangent is also cosine over sine. And that is written somewhere in our notes before as well, but in case you don't remember it, here it is again. Cotangent is cosine over sine. So since we have cosine over sine in our problem over here, this is equal to cotangent. And so now that we've simplified our original statement into a single trig function without a denominator, we are good to go. We have cotangent of theta as our final answer. Do you guys have any questions on this one? Okay, I'm gonna put this in Delta Math. If you do have a question, interrupt me at any moment and I will be happy to help. So let's see. I think I could just type COT and it would be, yeah, COT for cotangent. And then you press the theta button. So you got cosine theta, or cotangent theta. Okay, let's do another. We got secant over tangent. Yay. Okay. So hopefully you guys have that chart written down from earlier because, because I don't have space to rewrite it. Yeah. Okay, let's replace secant with what it is in our chart. So secant is 1 over cosine. And tangent, I guess we should remember that tangent is sine over cosine, right? So then I'm going to put here sine over cosine. Okay. Pausing here. Any questions? Okay, so we need to get this giant mess of a fraction, 1 over cosine over sine over cosine. We need to get that into simplifying into a single trig function with no denominator. So let's do that. In this case, I see that we are dividing a fraction by a fraction. And I mean, there's a couple ways you can do it, but let's do 1 over cosine, which is on the top. And instead of dividing by sine over cosine, we can multiply by the reciprocal, cosine over sine. So remember that when you divide by a fraction, which is what we're doing over here, you can switch it to multiplying by the reciprocal. Does that sound familiar? I hope it does. We've done this before. So let me know at any moment if you have any questions. But so far, this is what we got. So now that we're multiplying this across, oops. You can cancel right now, or we can just multiply across first. I'm going to multiply across first. So we have 1 times cosine on the top, gives us just cosine. And on the bottom, we have cosine times sine, so I'm just going to write it out, cosine times sine. And then we can cancel stuff out, which leaves us with 1 over sine. And then finally, from our reciprocal identities, we know that 1 over sine is cosecant. And so finally, we have gotten a single trig function without a denominator, so cosecant. Any questions on this one? Okay. If you do, interrupt me, but I don't hear or see anything. Cosecant, that's not how you spell cosecant, there we go. Cosecant theta. Okay, I'll do a third example for you guys. Oh, we got some squares going on. At least we have variety in our examples today. Sometimes we don't, you know? Okay, so remember that tangent is sine over cosine. And remember that cosecant is 1 over sine. Okay? So let's rewrite everything out. We have sine over cosine squared. Oh, and then I don't think you guys have seen, well, I'm not sure, maybe you saw this last year, but if you see the squared happening here, it means the tangent is being squared. So literally, tangent squared theta, this means tangent theta being squared, okay? So I'm not sure if you've seen that notation before, but telling you now, when you see this squared, even though it appears like right over there, that's what it means. Even though the squared appears like inside the tangent, it just means that tangent is being squared, okay? And this one would mean that cosecant theta is being squared. Why do they write it there? I'm not quite sure, but now you know. Okay, so we have sine over cosine squared times cosecant is 1 over sine being squared. And so if we're going to write this all out, we have on the top sine theta squared times 1 being squared. So 1 squared is just 1. And then on the bottom, we have cosine theta squared. And then we also have sine theta squared. Let me do some highlighting so you can see where things came from, just in case things look confusing. So the sine and the cosine turn into here, sine and cosine squared. And then this sine squared came from here. Okay, so just in case people were confused, like where is all this stuff coming from? The yellow parts came from the yellow fraction, and the green part came from the green fraction, okay? So any questions up till here? Okay. Then we can do some canceling. So we're going to cancel out the sine squared and the sine squared because you can cancel stuff if they're on the top and the bottom. And then we are left with 1 over cosine theta, which is squared. Okay? So I'm going to rewrite this. This can be rewritten as 1 over cosine theta squared. Because technically 1 on the top is the same thing as 1 squared. So I can rewrite the 1 over cosine squared as 1 over cosine squared. And then I'm just going to zoom out like that so I have more space. We know from the beginning and from various times in our notes that 1 over cosine is the same thing as secant. So we have secant theta being squared. And remember, we can write this as secant squared theta. So this would be our final answer. Okay, so this one was longer and it had some squares in it. Are there any questions on this example? Okay. So essentially the goal of this section is to break everything down into sines and cosines. So if it's 1 over sine, 1 over cosine, or sine over cosine, just break everything down into sines and cosines, cancel stuff out, and then you'll get your answer, okay? So that's the main goal of this. Break everything down into sines and cosines, cancel everything that you can, and then you'll get your answer. So our answer here is secant squared. Let's see how to type that, SEC for secant, and then going back here, if you press the A squared button, I'm just gonna screenshot it so I can point to it. That button, you'll get the squared symbol, so that's what I'm gonna press. So let me do that. Secant squared, and then, oops, secant squared theta. Okay, so that's it for this section. I'm gonna stop the recording for here.